So if you use your calculator, you would get 207.345, but 66 pi is your best answer. Okay, this is the best. Any questions with that? How I did that, what I did? Okay, if you are stuck at all, just please ask. Ask later after class. It just takes 10 seconds and you'll totally get it. For a triangular prism, we have two congruent triangular bases. No, sorry. Okay, so the area of one of them would be base times height divided by 2, and then you would have to multiply by 2 at the end. Now, what's the base and the height? Pardon? Nope. 5 has nothing to do with the base or the height. Yep, Tikshan? 3 and 4. Okay, it doesn't matter which is which as long as you use those numbers. 5 is the hypotenuse. It has nothing to do with this thing here. What is this thing that I'm circling? The right angle. That's what you always got to look for in your triangle. What's the right angle? Okay. Now we're not going to carry out this calculation because this is just review. But you have 3 rectangular faces. All of them would be times 10. So 10 times something, 10 times something, 10 times something. They're not all going to be the same number. Now for this triangle, they're not. What are the 3 numbers? 10 times what? Sarah, one of them.
4, 5,
Good.
and 3.
4, 5, and 3. Good, all 3 of them. Okay. So there's 3 different rectangles. There's a blue one at the front, a green one on the back right, and a red one on the back left. Don't get caught up with the triangle always being the same. Okay. Yes, we do have equilaterals where all 3 numbers are the same. Yes, you will see some isosceles where 2 of them are the same, but always assume that there's 3 different rectangles. So don't rush. Okay. Be careful with the numbers. Okay. Quick little review. Now we're going to go on to today's stuff. So, what we do is we're going to start with this shape. We want to find the surface area of this shape. It's called a composite. It's more than one shape put together. So what the textbook likes to do, and I kind of like to do this as a good beginning stuff, is to take the shape and split it into 2 prisms as if that shape was separate. Then what we do is we have to be careful because when these join together, those are what we call overlap. The overlap would never get painted. It wouldn't be the surface area. That's like dipping a donut into ice and sugar. All right? So, right before lunch, good one, eh? So when you dip the donut into the icing sugar, all of it gets covered. But inside the donut, it's not covered. There's no icing sugar inside. It's only on the outside. Okay? And that's what we got to be careful of when we're doing this stuff. So what we're going to do is find the area as if they were separated, then find the overlap. Then what we do is add the area, but subtract the overlap. Okay, so that's the method we're going to take. There will be some exceptions, but generally that's the easiest way. So, A, find the surface area of the rectangular prism. So we're going to pretend it's separated. So we're going to have an 8 by 3, an 8 by 4, and a 3 by 4. Those are the 3 different sides: top, bottom, front, back, left, right. And we'll have to times them by 2 because we have 2 of each type. Okay, remember they're separate now. So quickly go into your calculator. 8 times 3 is 24. Double it. It'll be 48. 8 times 4 is 32. Double it. 3 times 4 is 12. Double it. Good. Then add them all up. So 136 centimeters squared. Okay. Sarah.
For the 8 times 3, could you just, instead of doing it, just not times it by 2?
Yeah, add them all up and then times by 2 at the end. Is that what you're saying?
Well, no.
Oh, I know what you're getting at. Yeah. And that's very... Absolutely. The problem is we're going to see shapes that don't overlap completely. And that's why we're doing this method. So for example, if this cylinder was sitting here, there's stuff that's not overlapped, and that's why we got to be careful when we're doing this method. I totally agree with you, right? And that's how, like, when you get after a couple classes with an expert, you're probably going to want to do it that way. But for now, let's just kind of take a step back, okay? So next, find the surface area of the triangular prism. So now that's the top shape, okay? So you guys can see that on yours. The base is what? 8. Okay, and what's the height? 6. Okay. So it's going to be base times height divided by 2. Yeah. 24. And then double it. So it's going to be 48. I always like to divide by 2 so we can see exactly where it is. Tony? You totally could in your calculations, but I wouldn't write that down because if you write it down, it's going to look like it's a rectangle. Right? So as you're doing this, totally do that in your head as you're doing it. But just I would be very careful not to do that as I write it down so I can see clearly, oh yeah, triangle, that's right, 2 of them. Otherwise, if you just go equals 6 times 8, what does that look like? Rectangle. So that might confuse you a bit, okay? So do it in your head, and that's great math. That's totally awesome stuff. Just be careful when you write it down, okay? So then we have rectangular bases, which all have 3 as their width. And so we're going to get a 6 times 3, 8 times 3, and a 10 times 3. And then you get the total. Okay, what's your area total for the prism? $120, is that correct? Centimeters squared. All right. So now we go about talking about overlap. What shapes are overlapped? 2 rectangles. So find the area of overlap. It's going to be 3 by 8. Is that correct? Okay, so it's right here, 3 by 8. Yeah. So 3 times 8, and then you can double that, times it by 2. Oops, use the right pen. Okay. So 48. So total surface area now, add the shapes up, and then what do we want to do with the overlap? Subtract it. So you got to take your overlap and take it away. And you get 208 centimeters squared. Okay. Any questions? Once, twice. Moving on then, next page. Okay. So here we have 2 cylinders overlapping. Because they're both cylinders, when you're done, your final surface area would be like 425 times pi. Don't go to your decimals. Okay? Let's see how much time we got. Okay. We're going to go pretty quickly with this one, all right? We already practiced a cylinder once, so I'm going to go quickly with the cylinders. 2 pi r squared plus 2 pi r h. So this is the top one. What's the radius of the top? 7. Okay. Um, 7 squared is 49 times 2, 98 pi. On the back, 7 times 5 is 35. Double it is 70. Add those together and get 168 pi. We're okay with that? Alice, question? Nope. Okay. Next one. 2 pi r squared plus 2 pi r h. 2 pi, the radius is 13 squared, that'll be large, plus 2 pi times 13 times 5. So this is going to be 13 squared is 169 times 2, 338 pi, plus 26 times 5, 130 pi at the back. $468 pi altogether. Okay. I know I went super fast. Okay, I'll give you a second to catch up, okay? Any questions, just shout out, ask. You guys okay? So then for the overlap, what's being overlapped? Well, there's a circle here on the top cylinder and a circle here on the bottom cylinder. It's also covering up. So it's going to be what? 2 circles. Okay. And it's the small ones, so make sure you go area equals 2, we got to double it, 2 pi r squared, because there's 2 circles. And the radius of the small one is 7. So that's going to be 7 times 7 times 2. Remember what 7 squared means, 7 times 7, so 98 pi. Okay. And the whole reason why I wanted to show you this surface area is add up 168 pi plus 468 pi, but then you have to subtract 98 pi. So you're not doing any multiplying, you don't use your calculator for the pi stuff, just add or subtract the front numbers. So 168 plus 468 minus 98 equals 538 pi. Okay, so we're just going to leave it like that as a multiplication statement. Exact answer. How's that? Okay, not crazy stuff. So the last one here is the barn. Now, over here, this object is a 3-dimensional object. It's nothing real, so we have to calculate the bottom. But for a barn, would we calculate the bottom of the barn? No. So what we're going to do now is change what we've done a little bit. We're not going to include the overlap at all in our calculations. So for the what shapes have we got here is we have a rectangular prism plus half a circle. Sorry, half a cylinder. So the cylinder we'll have to divide by 2. What we're going to ignore is the inside. Okay. So for the top object, surface area equals 2 pi r squared plus 2 pi RH. Fill in the radius and the height, please. do 7.5 squared. That's the radius. And the height is 20. For the cylinder, the height is 20. It's lying on its side. So you got to be super careful there. So now you're going to use your calculator for sure. 7.5 squared times 2. 112.5 on the back. 15 times 20 essentially. 300 pi. So total surface area is 412.5 pi. Then what do we have to do? Divide by 2. And we get 206.25 times pi. Okay. Good. So now we're going to do what Sarah was talking about earlier. Let's just not include the sides not needed. So all we have is a left and a right, and a front and a back. Do not include the top or the bottom. They're not needed. That way we don't have to subtract anything later. Okay, so we're just going to omit the calculations at the beginning. So left, right will be 12 times 20 times 2. 15 times 20 times 2. We're going to assume everything at the front gets painted, okay? Even that little door stuff. That is an assumption, but we don't say that it's not painted, so we'll assume that it is. Yeah, we're going to assume that gets painted too, right? Because it doesn't say anything about it, we'll just assume that, yeah, it does. In real life, would it? Probably not, but we don't know for sure. So we will assume that we are, okay? Good job noticing that. This is 600. Total is 1,080. So for this object, 1,080 plus 206.25 pi. Now you got to go to your calculator and you got to get decimals. 206.25 times pi. Make sure you use the multiplication button. You get 1727.953. Okay. Let's round to the nearest tenth. So what's our answer if we round to the nearest tenth? Round the 9 up to a 10, and this becomes 28, and that'll be meters squared. Okay, so nearest tenth, got to round properly. Any questions? Okay, for your homework, so photocopy a little bit weird because our notes are 3 pages. So your homework is right here. Now there's one sheet that's all kind of messed up because the numbers are messed up. Trust the numbers. What's at the bottom of the page where my pinky finger is? Answers, okay, and they are accurate. Do not use rounded answers in further work. Try to use the exact number in the calculator. If you get stuck on that, use like 4 decimals in further work. Okay? Keep lots of decimals, 4 decimals. But only round final answers. Okay? All right. Again.
Yeah, you do. I know.
I'll take you. Can you do that at home? Okay, try this out. Just let's go. Yes. How
many questions on the page?
Yeah. Okay. So for this one,
No, but did you like the power square?
That's another question. Well, the bottom's a little tricky. So what you do is here you have five pieces of sugar. And here you have one piece of sugar. And at the top, there's four squares. One square is being covered by the top. That's the weird part. Because the top is only one square touching it. It's covered by one square. Doesn't matter what position, only one square is covered, and the bottom is one square. So I'll show you the switches. Right? Here's the square. One square, doesn't matter where I put it, how much is being covered, and how much is covered. Doesn't matter where it goes. So for the second one, there's only three in it. So one is having three squares. One is because this one is one square. Over here, three one square, three one square, three one square. And the same thing on the bottom. This middle row is four squares, so it's got to only cover four squares on that very bottom. Yeah, there's three other things.
Okay, so what?
Mr. Barker's all word punctuation. We also do it on our website. Now, if it's not loaded, I've had some problems with it. If it's not loaded, just let me know. Yes. Oh, yes. Not one of I think mine's cold boy allergies. Oh yeah.